All right, guys, welcome back, and let's continue. We are going to now do part D, okay, which is finding inverse functions, okay? So finding inverse functions of our logarithms, okay? All right, and so let me just give you an example. We will have the logarithm that is y equals 6 to the x. Okay. All right, and remember, if you remember anything about inverse functions, you have to switch the x and the y first. Okay. Let's start off by doing that. I might actually discover an easier way to do this as we go along. So let's just kind of do it first, okay? The main thing is you switch the x and the y, and then you solve again for the y, okay? So let's switch the x and the y. So we have x equals 6 to the y, okay? And then we want to solve for the y. Well, remember, the y is the power, okay? So if you want to get the power by itself, that's when we use our logarithms, right? Okay, so the thing you want is to switch the forms, okay? So remember, we want to write it as the logarithm. So it's going to be the logarithm, okay, of what's the base? Okay, the base is 6. Okay, so log base 6. Now you're not going to put a y here because the y is the power. Remember, the logarithm will always give us the power, so that's where the y goes. So the only thing left to put here is just the x. So it's the log base 6 of x equals y. Okay, and that right there is my inverse function of this. Okay, so one thing you might want to do is write this. Remember, f of x is y, but since this is an inverse function, you want to write it as f inverse of x. Okay. Well, here, let me write that first, actually. That way it's going in the right order. Okay. So this guy right here is going to be your f inverse. So we'll just call it f inverse of x equals log base 6 of x. Okay. All right, so that's our inverse. Okay, so again, switch the x and the y. One thing you might consider doing, once we switch, okay, remember this is f of x, y is f of x. Once you switch the x and the y, it's no longer the same thing as that, right? They're different. Okay, so one thing you might want to do is instead of calling this y, call it, once you switch it, call it f inverse of x, okay? Once you switch that. Okay, so we can just call this f inverse of x. I'm gonna leave it here. I'll leave it, don't bother changing it. Let's do another example. See if it works on the next example, okay? How about I do something like this? Y equals the natural log, okay, of x plus 3. All right. Keep in mind this is f of x, right? So if I call this f of x equals the natural log of x plus 3, okay, it's the same thing. I haven't changed anything, okay? So now I'm going to switch these two. I'm going to switch the f of x with the x, okay? And once I do that, this will no longer be an f of x, okay? It's going to be the f inverse of x. So switch the x out to the front, so you have x equals the natural log of, sorry if that doesn't look right to you, that's an L and an N. I think it's like log natural or something, like French or something. I don't know. Don't quote me on that. Okay, and then I'm going to put this in place of the x, but it's going to be the f inverse of x. Okay, and then it's plus 3. Okay, and now we have to just solve for the f inverse of x. But that guy is inside this big old mess, right? Okay, so here's what we have to remember. Anytime you're doing these logarithm problems, it's really good. It's a really good idea to be able to switch forms, okay? So remember, you're going to write the base and the power, and then whatever's left, that's what's left, okay? So let me just ask you this. If you look at this, can you tell me what the base is? Okay? Well, the base is written right down here, and you don't see anything. If you don't see anything here, what is the base? Now some of you guys might say, oh, that's right, if you don't see anything, the base is 10, right? Okay, but keep in mind, this is a natural log. So automatically, if you remember from our notes last time, remember the natural logs, the base is e, it's written as ln, the base is e. Okay, so our base is going to be e, so it's going to be e. All right, now if you're looking at a logarithmic function, remember, what do logarithms give us? Logarithms give us the power. So this big old logarithm is equal to the power, x. So my power is x, so e to the x, okay, equals whatever's left right here, okay? And that's going to be the f inverse of x plus 3. And keep in mind, if all we're doing is solving for the inverse of x, we want to get that by itself, so subtract 3 to the other side. So this is going to be e to the x, subtract the 3, and that's going to equal your f inverse of x. Okay, and now just write that first. If you want, you don't have to, but I usually like to write this guy first. F inverse of x equals this, okay? But still, that's the right answer, okay? Let's try one more. See if you guys can do this. Here. All right, try this guy. Y equals the log, okay, of 2x minus 1. Okay? All right. I would pause it, okay? Okay, here we go. Again, we want this to be f of x, okay? So f of x equals the log of 2x minus 1. Now switch the f of x and the x, okay? So this now is x equals the log of 2 times, this is going to be f of x now, but since we switched it, it's going to be f inverse of x, okay? Minus 1. All right, and now all we have to do is just get this guy, f inverse of x, by itself. So there's some unpacking we have to do, okay? Again, always switch the forms, okay? This is written as a logarithmic form, so now we want to write it as something as an exponential form. So what is my base? You don't see anything written here, right? So the base is 10. Because it's a log with nothing written there, the base is 10, okay? So the base is 10. What's the power? Remember, logarithms, no matter what it looks like, it always gives us the power. That's this guy right here. So the power is x, okay? And it equals what's left right here. So that's 2 times the inverse function of x minus 1, okay? Now, let's solve step by step for that guy. So add 1 to the other side. So 10 to the power of x plus 1 equals 2 times the inverse function of x. And now to get that by itself, we have to divide by 2 to the other side. So 10 to the power of x plus 1 divided by 2, that is my inverse of x, okay? All right, so there's that. Now there's one last thing I'm going to show you. This won't be on your homework for today, but it will be on your homework for our next section. So let me show you real quick how to graph. So what are we on? Part E. Okay, graph log functions. And they're all basically the same. So I'm not going to get too carried away. Let me just show you one quick example. Okay, they all pretty much work the same. I might show you two just for kicks. All right, so let me give you this. Y equals, okay, the log base 3 of x. Okay. And what we want to do, okay, since this form is, I'm sure, pretty difficult or challenging at least for most of you guys to work with in your heads for now, what I want you to do is just switch it, okay? Switch this. Okay, what does that turn into? Okay, what's the base? What's the power? Okay, so to write this as an exponential function, the base is 3, okay? The power is y, and that's going to equal x, okay? It's a very standard, straightforward, basic move to be able to switch forms, okay? All right, so now check this out. Let's make a t-chart. X and y. Now what you have to remember here is that 3 to what power gives me x? If I list my x values, it's going to be kind of hard. If I say like -2, -1, 0, 1, and 2, you're going to have a hard time saying 3 to the what power gives you -2, okay? So I'm going to show you a trick. Start with the y values. Check it out. -2, -1, 0, 1, and 2. Okay? Now watch this. Plug in the -2 for the y. What's 3 to the power of negative 2? Well, remember, the negative flips it, so it's 1/3, and then square that. 1/3 squared is 1/9. So now we have this, 1/9. Okay? Do the same thing here. 3 to the power of negative 1. That just flips it, so it's 1/3. Okay? Plug in a 0. 3 to the power of 0. You should know that. It's 1. Okay? Here's the tough one. Pay close attention. Plug in a 1. 3 to the power of 1. Let's see. Carry the 1. It's 3. Okay? And finally, you do this one. 3 to the power of 2. Good job. It's 9. And now let's go ahead and graph this. Okay? We have 1/9 comma negative 2. So 1/9, here's 1, right? Here's 2, here's 3, here's 4, and go down 2. Okay, 1/9, go out 1/9 and down 2. So that's going to be like right there. Okay. Go out 1/3 and down 1. So 1/3 and down 1, that's right about there. Okay, go out 1 and up 0. Okay, go out 3 and up 1. So 1, 2, 3 and up 1. Okay. And this is go out 9 and up 2. I'm not going to count 9 out there, so I'm just going to draw my graph. It looks like this. It's a curve, and guess what you have there? You have an asymptote, don't you? Okay. All right. Let me check the time. Yeah, I don't know that I have time to do a more complicated example than that, but if you have questions, just get a hold of me, and I will be more than happy to help you. Okay? All right. Talk to you guys soon. Peace.